see if they like it or not. I don't know. They probably never watch it. Oh, okay. So many extra. Oh, because I can have like. Okay. All right. So, data from exponential functions sometimes don't display a proportional growth, right? Like sometimes it's been changed. When you look at these patterns down here, and you look at this letter A, you know, 7, 13, 25, 49, 97, and you're like 7, I can't see like a multiplication pattern, but I know it's exponential, right? So remember, like when we did that little warm-up, like a couple sections ago, I had you look at something like this, and you couldn't find it, but that's because I had added or subtracted something to it. So, this is kind of annoying, but you have to try to like kind of like work it out and see what has someone added or subtracted to every single answer, so and changed it in some way. So you basically have to find what to take away or add so that you can like get the pattern back. All right. So like let's try something like, you know, 7's kind of a crappy number because like I don't know. I guess it doesn't 7 doesn't matter, but like what I'm trying to say here is maybe don't write this down. So maybe like if I add 2 to this, maybe I'll make that a 9. Don't write this down. What if I add? What if I add 2 to this? I would get 15, 47. So is that a pattern now? Is that like a multiplying pattern now? No, it's not, right? Like it's wrong. So, all right. So I try to add 2. What if I just add 1 and I get 8, and this is now 14, and that's 26? Is that a multiplying pattern that you notice? No. So what if I take away 1? 6, 12, what would this one be? Oh, you see it? Now it's multiplying by 2. And so it just takes a minute to like kind of finagle it through and figure it out. And you know, nobody's going to be super rude and be like, I'm going to add 7.5 and then see if you can figure it out. Like, you know, 1 or 2 or 3, like add or subtract. So this one would turn into, what? Take away 1, 48. And this one turn into 96. So, oh, there is a clear multiplication. So we found it. Somebody took a problem and they added 1 to all these answers to get 7, 13, 25, 49, 97, right? Okay, so now do write these down. All right, so this is basically my function minus 1, right? Like I figured out, if you take all the original answers and take away 1, then that's what was happening. And then I could start to see, oh yeah, look, multiplication by 2. I could start to see the pattern. All right, and then at the bottom, we're going to come up with the equation of like what the actual function is. So remember that these over here, these are the true answers. And then someone has done what to them to get these original problems, 7, 13, and 25. They've added 1, right? So if I want to write a function or write an equation for what's going on here, I'm going to say, well, when you plugged in 0, you got 6. That was your initial value, right? So when you had a function and you had a problem to an x power, when you plugged in 0, you got 6. Well, if I was going to put a 0 for the x, that whole part wouldn't matter. It would just turn into 1. So I want you to still get 6, so where should I put the 6? I put it out front, right? Because that was my initial value. That's my initial term. Because it doesn't matter what this is, when I plug in 0 to anything, it's going to be a 1. What was the pattern? The geometric ratio or whatever was 2. So you were multiplying by 2, right? So this is the answer I'm going to get. When I plug in 0, I get 6. When I plug in 1, I'll get 12. When I plug in 2, I'll get 4 times 6, 24. But to get the original answer, I have to do what to all these yellow answers? I have to add 1, right? So if you figure out what happened here, basically it's the opposite thing for the function. So you adding 1 to this. Okay. So just a little figuring out. So it's still an exponential function, but when your exponential functions get moved up or down, then it ruins the pattern. So you have to kind of figure it out. All right. So let's see if you can do the second one. And I'll tell you some kind of adding or subtracting 2 to those answers. something with the number 2. Something about adding or subtracting 2. And then you start to see a pattern. Come on. If you stop doing it, then it'll go away in your brain. All right, so what did you figure out you could do? Add 2? Right. So if you add 2 to all these numbers, now it becomes something that's patterny, right? 12, 36. Oh, I see a pattern of multiplying by 3, right? All right, so yeah, we see a multiplication by 3 pattern. So there's my common ratio. There's my base to my exponent, right? So what did you have to do to g of x to get these answers? You had to add 2. So this is g of x plus 2. So someone, when they were doing the equation, must have taken these black answers and subtracted 2 from them, right? Right. So f of x equals, so they must have taken the answers I was getting and subtracted 2, but I need something to the x power, and I need an initial term. So what's happening? What's my common ratio? What's my b term, my base? 3. So 3 is the thing I'm multiplying by every time. And then what do I get right off? Like, I want to make sure that this produces 4. So what's my initial term, basically? 4, right? So this is my initial term right here, right? It's 4, but then somebody subtracted 2 from it. That's how I got 2. Very good? Good job. All right. Okay, the last one. Try the last one and something with the number, well, maybe I won't tell you. I won't tell you at all. But it's close. It's very close. So don't add or subtract too much. Okay, I'm just saying, if you stop using your brain, it'll die. Alright, so did you find if you add what? Add 1? Alright, so I'll put these numbers here, and then you figure out the rest of the answer. Right? Figure out the common ratio, and what's this? X plus 1. Alright, so write the blue one, write the formula. Here to think of how you got this, do the opposite to the equation. Alright, so let's see. So we got f of x. Oh no, I need blue. So what was my initial term? When I plugged in 0, I got 64. So 64 is my initial. I was dividing by 2, so that's a 1/2 x. But all these numbers right here, I got those by doing what to these values? I got them by subtracting 1, right? So basically the opposite of what you thought of up here. Very good? Okay, all right. So now you recognize that you have your initial value and your common ratio. We can find an equation for an exponential function, but we can only do it, we can't really do it when somebody's added or subtracted something to it. So if you've done a horizontal shift, a vertical up or down shift, it messes us up too much. We can't do it. But we can go ahead and do it if you give us 2 points, and we're not going to do any shifts or anything like that, up or down. You give us a combination and initial value, because those two things are like right there, and I can just plug them in. Or you could give me 2 pairs, which is what we did with the geometrics last time. So we're going to do this problem here. We're going to do it like by hand, annoyingly, and then we're going to look at it on the calculator, and you can just do it on the calculator from now on too. Okay? Which kind of could have done before, but I never told you. All right, so here we go. So for 0 to 30 minutes, the number of fans inside a large sports stadium can be modeled by an exponential function. So there we go. That's our keyword there. All right, and we got 0 to 30 minutes. So that's my like 0 to 30 minutes is my range, my domain. My domain, right? Okay. All right, where F is the number of fans inside the stadium, and T is the minutes after the doors open. All right, so also notice this. They're telling you about minutes. So later, they're going to ask you to do stuff, well, oh, change the minutes to hours or whatever. So you have to kind of like sometimes figure some little changes out with that stuff. Not in this one. All right, so 47 people at 2 minutes, and then there's 2,602 at 20. So right there, you've given me 2 points, right? So you told me that 2 minutes, because the time is my input, my domain, right? So 2 minutes produces 47, and then what's the other point? 20 produces 2602. All right, so good. So there's my 2 points. So we can do this just like we did with our geometric sequences. All right, I can use this idea that GK equals, I can do GN over here, and then R to the N minus K, right? You do that like same idea to find my common ratio. And then I also have to find my initial term, because 2 minutes is not my initial value. I mean, we might kind of think to ourselves our initial value is just 0, but you can't have 0 in exponential, so whatever, we'll figure it out. Okay, so what's my later term? My later term is 2602, and what am I going to put for GK? I'm going to put 47. So if I have these 2 answers, I can put them here, and then what could I put in N minus K? 20 minus 2. This is like just like you did with sequences. The second term is 47, the 20th term is 2602. Find the R value, all right? So we're going to put 2602 equals 47. We don't know R, but I know that you multiplied by something a bunch of times to get from 47 to 2602. So up top, I'm going to have 20 minus 2. So obviously this is like super gross, like 18th power, like what the heck's that? But basically I have 2602. Oh, I didn't make enough space. All right, hang on a second. I'll write that a little smaller. All right, so 2602 over 47 is equaling R to the what? 18. All right, so it's ugly, but my R value is the what root of that fraction? The 18th root, right? So my R is whatever that heck that is, 2602 over 47 to the 118. Okay, so, and again, I want to keep that in its truest form, so don't necessarily like turn it into a decimal or anything like that. Just keep it as long as you can. Right? Okay, but actually, why don't you find it real quick just to prove something else later. So go ahead and do that in your calculator real quick, just to kind of like prove something else we're going to see in our calculator later. So just make a fraction, or put it in parentheses, and do division, and then put 1/18th power. Very good. 1.2498, so keep as many decimals as possible. All right, so now, if I want to write the actual answer, I need the initial value, okay? So if I want my initial value, why don't we go ahead and let's use this guy right here and like help me find my initial value, my like G0 in a way, okay? So if I want to find my initial value, then I'm going to use 47 equals, I don't know my initial value. I'm going to try to find G of 0. And I have my R value, I'll leave a big space for that, but what's going to be in the exponent up here? Because 47 was my what term? My second term, and this is my 0 term, right? So I'm going to put 2 minus 0. Follow? I'm trying to find my initial value. So inside here is going to be that 2602 over 47 to the 118. All right? So what's going to happen is 2 minus 0 is 2. What's 2 and 1/18 going to do? They're going to multiply. So 2 times 1/18 is 2/18. What is 2/18 reduced to? 1/9. So I basically have this. 47 equals G0 times 2602 over 47 to the 1/9. So what are you going to have to do to solve for G0? I mean, this whole mess over here, this is just a number. This is just like an answer. So what are you going to do to solve for G0? By that mess, right? So 47 divided by that. So obviously, like, we're not going to be able to get away from just like getting a fraction, you know, like a decimal or whatever. All right. So let's do it. So we got 47. We're going to divide it by what do we want? 2602 divided by 47. But that has to be to the what power? 1/9. Okay. All right, there we go. Now, you see these numbers we're getting? You see them down here? You see them? All right, so 30.089 we'll say. Okay. So if I want to write my equation, I mean, I have it now. So I'm going to write GK, GN. I'm going to write F of T. Take it?
Shouldn't it be a whole number?
So yeah, but it's just not. I know what you're saying. Yeah, but we're gonna keep it to its true form until like later if they ask me a question for it. All right. I see like logically what you're saying. So all right, what am I doing? I don't want G. I want this. The name of this thing was F of T. All right. So my F of T is this, and you could also write it. If you ran out of space, you could like write it right here also if you want, because we're going to show you how to get that. So I have my G of 0, 30.089. My R value is going to be my 1.2498, and then I have the X value. Right? So that's how you do it by hand. Like you already kind of know how to do that. I mean, it's kind of tedious and pain, but like you already know how to find R in that format. Okay. All right, so let's see how to do it on a calculator. Very good? Okay, so why don't you guys clear your calculators if you're using one of mine. Clear them because the other two kids were using it when they were attempting their test yesterday. It goes too well for some, but whatever. Okay, all right, so I will clear mine too. All right, here we go. So you have 2 data points basically, right? So 2 data points. So how do you put data in your calculator? Huh? Stat button. All right, press the stat button. That's it. Hopefully that's list 1, list 2. If not, let me know. And then put your stuff in. You've got this information. You have 2 and 47. So they'll make sure they're across from each other, right? 47. And then you have 20 and 2602. All right, and we have turned this information. It was an exponential function. So you did this last year in Algebra 2, but press Stat. Let's go to Calculate, and we need what? Linear regression, quadratic regression. Yes, number 0. So if you go all the way down to 0, there's one called exponential regression. So there it is. It's number 0. Okay, so press 0. store it in Y1, just like we did another chapter ago. And you will bypass all the work we just did and come up with the answer. Okay? All right, so most of the time, we can just do this. I just want to show you and prove to you, like, you kind of recognize it. So we're going to do this from, like, now on and on your homework and stuff. Like, when you see this little calculator thing, like, we're going to do it on the calculator. Okay? But there they are right there. But you saw how we kind of came up with them, too. So if someone asks you, hey, what's going to go on in the 25th minute? Like, how many fans are in the stadium at 25 minutes? What are you going to do? Right, so we can clear that out of there because it's in y equals right now. Right, so I do, how do I get y1? Alpha trace, and I could plug in, oh, whoops, trace. I could plug in 25 minutes and see how many people are in the building. Oh, there's almost, 7,934. Okay, very good? All right, so this is going to go quick. We're going to do in our calculator. All right, so pop those in your calculator and find a formula. What happened here?
Talking about the slider thing, and I'm talking about the
slide rule. We always, we always talk about a slide rule, blah blah blah, and none of us only one of Mr. Micah knows what a slide rule is. The rest of us are like, what are you talking about? I've never heard of a slide rule. I mean, I'd have to watch a video on how to use it. All right, you got it? Got in your calculator? All right, so we kind of jumped the gun here, but let's go ahead and write the equation. So we got what? G of x equals, what was your a value? So give me a bunch of decimal points. Like the more decimal points, the better. Obviously, we're not going to write them all. It'll be all extra. Like, I'm going to write all of them. But 3, 4 of them, where it seems like a good stopping point. 16.8012. Is that good? Other people agree? All right. And then my b value is 0.639. Okay. So 0.6999. All right. Technically, I guess you could put 0.7 because that's really strong for 0.7. All right. But up top it said to use the data to write two equations that we could kind of use to solve for A and B. So you realize when you give you this data, right, you're saying that G of 3 is 2154, right? That's what that first thing says. But basically what you're saying then is you're taking this A times B to the x is 3. So this is equal to A times B to the third, right? I mean, that's what you're saying. G of 3 is when you plug 3 into that problem. And so this right here is an equation with the information you gave me in the first place. Okay? And another equation you gave me is that G of 8 is 3.62. So 3.62 should be equal to what if I plug what I know into this expression? A times B to the 8, right? So this would be two equations involving the information I know. So, this produces that. 3 produces 21.54. Okay? So, anyway, that's like a system of equations that you're solving in a way. Okay. All right. So, when we have something with the base E, remember E is just the 2.718, right? Like pi is 2.14. What comes after 4? Oh, should we have a pi memorizing competition one day?
We need Layla to be here.
Oh, there she goes. Right. Okay, so let's see. We got this there. Want to take a break for a couple minutes? Take a break for a couple minutes. Just to, want you to tell each other your favorite food at Thanksgiving. What's your favorite food? Or if you don't celebrate Thanksgiving, then just say that. What? Lollipops? Your favorite lollipops? Tell everybody your favorite Thanksgiving dish.
Great. That's my favorite sauce. It's not like the traditional cranberry sauce where it's like the others are in it. It's like the can one. No, I do love cranberries though. I mean, I love like craisins.
Oh, really? What about you guys? Oh, what's your favorite food at Thanksgiving? Isn't Woodbridge? They bring the meat and then you like put it on the grill. Yeah, so everything else has like a grill and they don't use like crazy meat.
What's it called?
It was, I don't know what the name of this place was. I can tell you where it was. It was in Shopping Center of Florida. It's right down near Potomac.
It's too much.
You want? Yeah. I mean, my husband is a son like that.
Yeah, that's great.
I don't want to cook my way. Yeah.
Oh yeah.
I mean, it was good though. Like, you have to wait a while and like, you know, it's like when you go to like a fondue place and you're like, oh, it'll be awesome, fondue, and then you're like, and you're eating, but then you're also, it's taking a while, so you're also still kind of hungry. Yeah, and so they have a bunch of different choices. It's like all you can eat, and then you bring the next food. Okay, ready? Finish up so we can get our little bit of classwork done. All right, so this next problem is going to be using something with the base, the natural number, the base E. So the number of bacteria in a particular culture can be modeled by this exponential function. All right, great. So, but do you notice like the things you did last night? This part right here, do you notice that you could change that? Like, what if I don't want that 0.31 in the power? So you learned how to change that last night, right? So, like last night, if you had something like 2 to the 3x, like what did you do to get rid of that 3 so that it was just something to the x? Yeah, like 2 to the third, right? Because this is like saying 2 to the third to the x, right? So you actually evaluated 2 to the third and you said, oh, that's really 8 to the x, right? So that's what this first part is asking us to do. It's telling me, okay, great, B is the bacteria formula, but make a new formula that's basically equivalent. It's like the same graph, you know, same answers, but I want it to be like nice and clean. All right, I don't want this like 0.31 with my exponent and all that. That's kind of annoying. All right, so we know how to do that already. So A of T is going to be nice and clean. Now, if there was a number in front of here, like if there was like a 5 in front of here, it doesn't disturb the 5, right? And like, well, now I got to put a 5 over here to make it look right. But yeah, it doesn't disturb the leading coefficient, I guess you could say. All right, so 17 is going to say, and basically, I'm going to say that I have e to the 0.31. And then t. Okay? Yes, it is. Oh, okay. All right, so let's go ahead and do it. So on your calculator, so 17 is not disturbed, right? You're going to figure out something to the t. On your calculator, there's 2 places where you can find the e. All right, there's one over on the right side. That's above the division key. But if you know you want to do it to a power, over here underneath ln, it's going to automatically put a power. I mean, it's just one less button you have to press, but so you can do that one, and then it immediately asks you for a power. All right, to do it, find me e to the 0.31. One point three six three. Okay. So how about 3634? How about? So 1.3634. Okay. So there we go. My A. So here's my A and here's my B in this equation that they're asking for. Okay. So it's basically like the cleaner version of it. Okay. So why don't we go ahead and let us, so, you know what? I don't want to use this rounded off stuff right here. So, to keep it like true to its form, let's go ahead and we're going to put this in our calculator, but put this format in your calculator. Or put the original in your calculator, either one. So either this green or this yellow one. Put that in your Y1, your Y equals. Because I don't want to use a rounded off decimal because then it like doesn't give us like the perfect answer. I mean, I don't know why I did it that way. I should just put the x with the 0.31, but why does it matter? All right, I'm going to use x instead of t. So this next question is asking us to find the average rate of change. I got to plug in 1, then I got to plug in 7, right? So now that it's in Y1, let me just use my calculator to do it, okay? So, because like it's going to be a lot of decimals. I would rather use the whole decimal, and that's the calculator will do. So if I want the average rate of change, average rate of change for, let's see, what do I want? Average rate of change, I want from 1 to 7. So I'm definitely going to do 7 minus 1 on the bottom. What do you want me to say on top? Plug in 7 into what? Into Y1, right? So I'm going to plug it into B. B or A. You go to A or B, they're both the same thing. So I'll just say B because they told me B in a problem. I'll be doing B of 7 minus B of 1. Right? But the calculator is going to do it for me, right? So my B is going to be like Y1 of 7, right? Okay, so make yourself a nice little fraction and basically type that in. So we want alpha trace, we want Y1 of 7 minus Y1 of 1 over 6, right? All right, so you type it in. Make a fraction. Type it in. The answer should be something 20 something. Yeah, okay. Just so you know you're right. All right, so 20.9521. Okay. So 20.9521, but actually, oh yeah, that's fine. So this is how it's changing. The bacteria, so is the bacteria growing or dying? It's growing, right? It's growing by about 20 every hour, minute. What is this? Hours. All right. About 20 every hour, almost 21. Okay. Now, here comes the trouble. All right. To find the value of t. So these problems gave me t and I found the value of b. That's easy. I can do y1 of whatever. But they're telling me to find the time when the bacteria grows to 1,000. All right. So imagine this. Let's draw a little picture over here. So imagine what's going on here. I have this bacteria, and based on my original problem, when I plug 0 in for time, how many bacteria are there? When you plug 0 into this problem, you get 17, the initial value. So 0 is 17. So great. That's 17. But then it's growing. And I know 1.3 whatever, so it's growing. So it comes over here. Obviously this part doesn't matter, but it's coming up through there and growing. Right? I'm trying to figure out what time produces 1,000 bacteria. So I'm trying to see 1,000, like when is that over here? I'm trying to go over here. I want to go 1,000 comes from what? And so that's my question. I know times 0 is 17, but I don't know what produces 1,000. I mean, I suppose if you're desperate, you could just keep plugging in different hours and see if it grows. But obviously it's going to be pretty big. So we're going to go ahead and make a graph, and we're going to put in 1,000, and we're going to see where they match up. All right? So basically what we're trying to do is this. We're trying to see when 17 e to the 0.31 t, we're trying to see when does that equal 1,000. And I could have used the earlier formula or the yellow one, like it doesn't matter which one. So later, when we do logarithms, like you can actually solve this equation. All right, there's like a way to do it. We don't have to do it on our calculator, but for now, we're just going to find the meeting point. We're going to find, like, where does this happen? Okay. All right. So I have the two problems in there. I have my one function. You guys already put that in there. And how do I get a line at 1,000? What should I type in? y2 equals, I mean, it's a horizontal line. Well, y equals 1,000, right? Okay. So I'm going to go ahead and put that in and say to myself, okay, well, I already got the other problem in there. I want another line at 1,000. All right. So I press graph. Oh, there it comes the other one. All right, it's really looking sucky to me. I can't even see the 17. I can't even see like where you crossed. And I definitely can't see 1,000. So what do you gotta do? Change my window. Change, more importantly, my what value? The y, the highest y. So basically, my y height, my window, I want to make sure that my height definitely gives me 1,000, right? So let's make it like 1,020, right? But do I also need to see like over to the left anything? No, we'll just start with a 0. So 0, and then I don't know how big I'm going to have to go. So why don't we just do like 100? I don't even remember. I kind of don't even need to see down here either. So let's put 0 there too. So I kind of wanted to see the first quadrant, right? All right, let's see. So now, there's the problem. 1,000 should be coming. There it goes. All right. Now, you see this little like thing, that little snaky thing over in the corner? It was telling you that it was working. If for some reason that little snaky thing gets stuck and it just won't stop, if you press the on button is like a pause. It stops the graph, and then you can go back to the main window or whatever. Anyway. All right, so I want to know where they intersect. What are you going to do? Second case. Oopsie. A second, I guess. Number 5. And then just press enter 3 times. So, to get to 1,000, about 13.14. Let's just say 13.14. All right. Okay, so the time is 13.14, and we gotta label it minutes, hours, what? Hours. Okay. Last big one here, and then the multiple choice ones on the next page will be pretty quick. Okay? All right. 50 deer were introduced to a large wooded area. So that's telling you what? A or B in my equations. Tell me my A value, my initial value. All right. So great. 50 deer. So I basically already know that A is 50. Large wooded area. The population of deer in the wooded area can be modeled by this function. All right, great, exponential. T is the number of years for now, since the deer were first introduced, and the population increases by 13%. So every year, you're going to keep what you had, and you're going to add 13%, right? So, like, what percentage is that? Keep the 100 and you add, so 113%, right? So if you want your B value is your rate of growth. That's 113%. You're keeping the 100 and you're adding 13 more. So what's 113% as a decimal? 1.13. It should be growth. It should be over 1, right? So my B value is 1.13. Because the 1 makes you stay the same. And the 0.13 lets you grow a little bit. Okay? So every year you're growing by 13%. That's what this says. All right, so let's go ahead and write it. So D of T equals, we got 50, 1.13 to the T, I guess. All right. So next thing, wants to know how many deer are there in 6 years? Because maybe I have to let the hunters, come out because the deers are getting too many or something like that. So what we're going to do to find what's happening in 6 years. Yeah, plug in 6. So, D of 6. All right, you do it. What do you got? Let's see. 37 something? What do you get? Was it 37? Did I do it wrong? Oh no, that's the next one. Sorry. I didn't actually do the answer. 37 is the next one. Never mind. What'd you guys get? 104? Okay. Sorry, that was later. So 104.097. All right. But actually, we're just looking for the number of deers. And yeah, so 104, we'll say 104 deers. A deer. I don't think you put an S on it. I think deer is like a plural to begin with, right? Take a look at your English teacher. All right, so letter C. I want to know when the population of deer is 5,000. So I'm interested in knowing when 5,000 equals 50 times 1.13 to the T. So obviously, if you wanted to guess and check, you could keep, if you had a multiple choice, you put the time in, see if it comes out. But right now, the only way I need to do is make a graph. So if I make a little picture, what's my initial value? 50. So it's me costing at 50. It's growing. We're interested in when it becomes 5,000. And I need to know that. All right. So you guys already have this, or no, put this in, put D of T in your Y1. Graph 5,000. Figure out where they cross. So you're gonna have to change your window. Change your Y max to something above 5,000. Same one's before. Your window, maybe to like 6,000 or something. Where'd you get it to meet? Was this one 37 something? This was a 37, yeah? Yeah or no? 37. Yeah, okay. Alright, this was the one. 37.68. And we're still in years, right? Okay, so here comes a part where it's a little bit weird, but also like not that hard as well. Okay? So sometimes, and you'll see in the multiple choice, that'll be really quick on the last page here, we're almost done. Alright, I'm gonna ask you to change the time in some way. Alright? So we're gonna do this now in months instead of years. So we're gonna change D of T. So my initial value is still my initial value. It's still gonna be 50. And the 1.13 is not gonna change for now. But I have to change that time up there to be months instead of years. So imagine what has to happen here. This 1.13 is over the whole year. And so how many months in a year? 12. So imagine this 1.13 is not every month. Only like a 12th of it is every month. You follow? So what I have to do to my exponent up here is I have to say, well, this growth rate, I only really need a 12th of it. It's kind of like I'm splitting it among 12 months. So the time, whatever time you put in here, that growth rate needs to change. It needs to be a 12th of this value because it needs to be monthly instead of yearly. Follow? And then I'm still going to put my t, and you're going to tell me the number of months and then whatever. So what if I put 12 months? 12 divided by 12 is 1 year, and oh yeah, I'm putting in 1 year, right? What if I put in 24 months? Well, it turns into 2, and it would be like this problem with 2 years, right? Okay, so basically you can say this, it's 50, and then you have 1.13, and that would be t over 12. Okay. T over 12. Okay. So think about the rate, and think about how it's growing, or like, you know, how you need a little bit different number. All right, so that's what these two problems are going to be doing for us here. I'm just going to underline real quick. I almost done, I promise. I'm sorry. The value in millions of dollars of the transaction processed by an online payment platform, so like a bank or whatever, is modeled by this function m. All right. So the value is increasing by 6.1% each year. So that's telling me my r value. So the m of t. So what's my r value? I'm increasing by 6.1%. So it's 6.1% plus 100 would be 106.1. So what do I want here? 1.061. So you have to take your percent and change it to a decimal, basically. This one? All right. At time 0, it's 54. So they just gave me my initial value. Okay? So let's increase at time 0 years. So if I put a t up here right now, this is for years. Okay? So 1.061 is the yearly increase rate. Yeah. The next part it says, well, what if I change m of t and it says, blah, 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 if t is measured in years, which is, what does it say? Oh, no, wait a second. Oh, a quarter. I'm sorry, I got it backwards. So this is not for years, this is for quarters. For quarters, like a fourth of a year, like 3 months, right? So this rate is only for a quarter of a year, right? So I'm trying to change this to be years instead of quarters. So how many quarters in a year? 4. So if you want this T business, if you want it to count for the whole year, what you'll have to do to this rate, since it only counts for a quarter of a year, is you'll have to basically take this rate and kind of like do it to the 4th power, because you want it 4 times for 1 year. So you'll do the 1.061, you'll be doing it to the 4th. See what I'm saying? So you have to increase the rate by a multiple of 4 to get it to count for the whole year, because right now it was only for a quarter of the year. Right, so you see the answer you want? Letter D? Always letter D. So I guess pick letter D if you don't know. All right, last 2, we're almost there. So we got iodine has a half-life of 8 days. So great, they told me that. They're giving me the formula right here. So that 8 is getting put right there. So half-life. So look, half is going to be left after 8 days. So if you put an 8 right here, 8 over 8 is 1, and so you'll be multiplied by half. If you put 16 in here, that'll be a 2 power. So it means you'll have lost a half of it twice, right? So they've already made the formula for you. Okay, so we're in days. Says A0, nobody needs to know A0, so great. So, which of the following functions is going to talk about hours? Okay, so imagine this 0.5 to the d over 8. That is in, oh my god, I'm totally messing up right here. That is in days, yeah? 0.5 d over 8. This is for days. All right, so this rate, this 0.5 is for days right now. And I want to change it to hours. So do I want to reduce that rate, that 0.5, or do I want to make it bigger? Right now it's in days. So if I'm going to have an equation for hours, this number, this 0.5 needs to get smaller because it needs to account for, it's only a 24th of the day. You follow? 1 hour is a 24th of the whole day. So if I'm going from days to hours, I need to make it smaller somehow. So I need this 0.5 to be smaller by how much? A 24th, right? So 1/24. So you need this to be 1/24th of what it really was. Because 0.5 was for the whole day. You only need a 24th of that to do it into hours. All right? So don't worry about the t or the d. Do you see which equation does this for you? To the exponent? Yeah, always answer D. Okay? So you see how the 24 and the 8, that multiplies to 192. Okay, that's what I'm going on. All right. So, water hyacinth is an invasive plant species. Whatever water hyacinth is, must be some kind of plant like hydrilla in the Potomac. You've heard of that? Hydrilla, that's in the Potomac and clogs everything up. It was a big problem like 20 years ago. It's a little bit better now. Anyway, like the seaweed stuff. All right. It grows at 7% a day. Oh, right there. You just told me the rate. So what should I put? I'll put 0.7. Okay. As a part of the study, they introduced 150. So there's my 150 in the front. So basically, this is my problem. I need to figure out the exponent, but, already I can tell which answers are wrong. Yeah, okay. So you don't add it like that. You have to do the percents together. All right, 150 testing pool. All right, which of the following functions gives the amount of water hyacinth in the testing pool T weeks after the sample is introduced? So this is the growth rate for a day, for 1 day. So this is a day, and 150. What would you have to do to that growth rate? Let's put T up here. What would you have to do that growth rate? If this is 1 day, how would I turn it into a week? So multiply by 7, because this has to happen 7 times before it's a week, right? So we're basically doing it to the 7 again. And which answer is it again? Letter D. So I'm not going to make it letter D when you take the test. All right. So let's say that. Let's cut it down a little bit. Why don't we say that? I don't know. Why don't you just finish the front of this, okay? Finish the front. Give it back to me. Put your name up top. Give it back to me. You don't even have to do it on the weekend. All right? Nothing. Do the front page and then we're done. That took a while. Everybody's tired. I'm even having lollipops left. Alright, so just do the front for me. Just the front. Basically, problems 1 and 2. And that's it. Come on, Landon. You made it. Brendan will love it. It's lots of buttons to press. You can imagine this on the calculator. Alright. So let's do the front page. And we'll take care of the rest. Yeah. What's here?
Good morning, Hops. This is just a reminder that as we prepare for the long holiday break, we want to make sure that we are limiting transitions and students in the hallway. So please, teachers, limit your pass giving to students that have an emergency. Students, if you need to use the bathroom or you need to go somewhere, please utilize the time during the transition, your 6 minutes to go to the bathroom. We are going to reduce the amount of passes that will be shared with students. So please be mindful about where you're transitioning to class. Again, teachers, please let's limit the hallway traffic and limit the passes out of the classroom. Thank you so much.
All right, so just do the front page there, and then that's it. And just give it back to me. Put your name on it. If you want me to check it or check any answers, let me know.